Ez külön élmény, így kihangosítva lenni ennyi ember előtt, úgyhogy köszönöm szépen, hogy ennyien eljöttetek. Are there any people who don't speak Hungarian in the audience? There was somebody else there, right? I can do it in English if it's not a problem for you guys. So I did the slides in English anyway, so I think it's going to be okay. So I'm going to start the 30 minutes. Okay, so in the first roughly 5 minutes of this talk, I'm going to talk about F#, which is this functional programming language. And then the rest, I'm going to do some demos. And hopefully 10, 30 minutes is going to be enough just for you guys to get an idea of what I'm trying to say here. So F# is a functional programming language. It's been developed by Microsoft Research about roughly 10 years ago. It's a really good language for robust software development. It allows you to write less code, and you can pack more functionality into the less code because it has a script-like syntax, et cetera, et cetera. I'm not going to waste time on this slide. You get the idea. F# is a wonderful language. Of course, every functional programmer says something like this about their favorite language, so I'm not going to stress this point. I really believe that F# is one of those languages that I feel comfortable with with developing, and I think it's a great language. But what are the key benefits, actually? So we mentioned that the code you write is considerably shorter than in other languages. I mean, some people try to put a number on this. It's usually between 3 and 10. That's a factor of 3 and 10. So instead of writing 100 lines, you may get away with writing 20 in F#, as opposed to, let's say, 100 lines of JavaScript or Java or Visual Basic or C#. So this is not because the language is just simply shorter and more concise. It's also because it requires a different mindset. So F# is a functional object-oriented language, so it's a hybrid language. But the fact that it's a functional programming language means typically that it's less code associated. So you can use all those functional, very powerful functional programming constructs, and because of that, it's really ideal for a wide range of domains. So far, people have been very successful in applying functional programming in numerical and symbolic computations, finance, et cetera, et cetera. But the key point here, and I believe you guys have already seen this today, that functional programming languages are really great for many things, but very appropriately reactive applications, distributed applications, parallel applications, etc. This goes back to the fact that functional languages tend to be immutable. This is something that is sinking into everybody's mind as you continue your programming learning. So immutability makes it easy for making applications run in parallel because there's no mutated shared state. It makes it a really great target for doing that kind of parallel or asynchronous applications. So another key point here to make is why F#? And I've been sitting up there, and I couldn't see anything about the slides, so I don't assume that you guys actually can see this. What this is it's a list from the TOB index, which is a programming language index that tries to rank programming languages based on a whole bunch of criteria. According to this, last year, F# was 38. This year, it's number 13, and it is the only language that has been gaining so much in popularity. In fact, it's the only or the highest ranked functional programming language at the moment, number 13. So getting into the top 10 means it's a good language. So we are about to hit that point, and hopefully it will happen soon. So I'm not going to get into this. I think we don't have time. Well, basically, the foundations of functional programming are listed there. So you have anonymous functions. You have higher-order functions. You have, first of all, you need parametric polymorphism. You need type inference that goes along with that. You need fundamentally different functional data structures. And then you have things or tools like pattern matching and active patterns and eager and lazy evaluation. So these are the cornerstones, the foundations of functional programming. There's no way I could explain these. Hopefully most of you know this already. Here's a little example on the right-hand side. I don't think you can read it, but that just shows you the syntax of F#. One of the key points about F# is that it's very widely available. It's been integrated IDE, so integrated development environment-wise, to almost all the major IDEs, including Visual Studio for .NET people, Xamarin Studio and Mono developed for Linux and Mac developers, and we have an upcoming so-called web ID called Cloud Sharper. You get a little bit of a glimpse of that today. So here's a couple of slides about syntax. So one, I didn't mention this on the slide, but I actually mentioned it in speech. So there are something called the active patterns. This is some very F-sharp feature. Here I show a couple examples. Maybe this is a slightly better one. So here we define what we call an active pattern, but it's a partial active pattern, which means that out of all these ints that could be parameters to this active pattern, it's trying to shave off things that it can categorize as a prime. And the way it can do that is declared here. So we basically take an enumeration between 2 and the square root of the n, and we're going to try to see if any of those numbers divide the input number. And if so, then of course we are not having a prime number. And in every other case, we have a prime number. And then once we have this active pattern case, we can apply pattern matching. Hopefully you can see it here. You can say, is this number a prime? So not very interesting, but it's a very powerful device, and people do a lot of different things with partial active patterns, including parsing. Here's another F-sharp feature called units of measure. Basically, you can annotate units to your numeric types. So here I'm doing some calculations with velocities, with distances expressed in meters, and we have units, meters per second, and so on and so on. And these are automatically inferred by the compiler. All right, so I think I've hit half of my time. Does anybody recognize themselves? Then they must have been here last year. I think this was a... You recognize yourself? Oh, that's pretty cool. So you are a faithful person because you came the second time at least. So thank you for that. So which one? And the last one? Because of me? Hopefully not. Oh, the last row. So you were sitting where? Here? This is you? Okay. This. Okay. So I took screenshots of what I'm going to show you because I didn't expect the network to work. So I'm going to maybe demonstrate 2 or 3 different things. Number one is an interactive session. So I'm going to go into an online IDE. I'm going to type different things. I'm doing it interactively. That's the main take point. Then I'm going to do some visualizations in the interactive window. And hopefully you will see that this is quite a nice environment to work in. And then last, I'm going to show you some basic mobile development example. So let's switch to Cloud Sharper. So what I did is I went to cloudsharper.com. This is an online IDE. It's the first IDE that allows F-sharp development online. It's actually a very nice IDE. Here I have an empty workspace, and I added a jQuery mobile application to it. That's going to be the last example, remember. So first I'm going to do some interactive development. So there's a key combination that brings up this pop-up window, and I can type all kinds of things. Probably you're not going to see anything out of this, but if I type, let's say, 1 + 1, it's going to faithfully say it's 2. I can define a function that adds a number, whatever. I can define functions, I can apply them, I can write expressions in terms of those functions. There's a whole bunch of built-in functions. So basically, this allows me to do just ordinary development, but online. Now, Cloud Sharper has this nice documentation section. So if I just hit up, how do I do charting in F-sharp or in Cloud Sharper? For a moment, I'm going to hide this window. So there's a nice little explanation here that you can all read, showing some examples. So let's just click on the first one. There's a big button on every snippet that says Send to Interactive. So by clicking that button, I'm going to be able to actually send that code into the interactive environment, and I don't have to type it in. I can type it in if I want to. And then once I typed it in, the interactive environment is going to parse it from F-sharp. It's going to interpret it, translate it to JavaScript, and run it. So this was a small little chart that I just did. Let's say we do another one. Here's a 4-line chart. I did a line chart. It's nothing fancy, but it's getting to be really, really powerful. So in fact, I could just turn to an online database. I could grab data out of it, and I could, on the fly here, dynamically and interactively plot. And in fact, I had an example for that, except that was in a different session. Well, OK, let's do the mobile application one. Actually, before I do that, I still have 4 minutes. So I'm going to do the interactive web development just to show a little snippets. So I could basically do things like this. In 2 lines, I'm going to send this to interactive. I want a button that if I click, it's going to say something to me. And in fact, now I got the button. I click it, and it said hello. in 2 lines. And of course, we can take this to the extreme. And then here's about 50 lines, that little something. I send that to interactive. It's going to basically do an HTML5 canvas. And I think it's too big for this particular screen size. But then it listens to my mouse events, and it allows me to draw. And remember, this is in the interactive environment, so I can go up and I can even change the code and then get a different updated version. I can still see all the things I've done before, and I can make them pop out into separate windows so I can work with them individually. So this is the interactive part. Hopefully now you understand why I said in the title of the talk that it's interactive, it's online, and it's web development because we are doing web development. In fact, here's a project that I have loaded. It's a jQuery mobile application. It's a JavaScript web-based library. So I'm going to run that right now. What it takes is basically like 3 seconds to compile this from F#, and it will generate a bunch of JavaScript and HTML. I open those HTML files, and then I view it in a split view instead of a regular view like that. I view it as a split view. That means I can make changes in the generated code, or I can just do a recompile, and that will update the code, and I'll see the result right here in the right-hand side. And basically, I can click around in this application, and I can already test it here. So this is a mobile application I have done. It's about 100 lines of F# code. And here's the code. And because it's an online ID, as you can imagine, I can make all kinds of editings. And once I start making edits, then you see I broke something. I just changed the code, so I broke it. I have a red line here that says, hey, I don't know what that is. And it gives me code completion and all kinds of other normal ID features that one would expect. And so that was one example. Let me try to load another example. I think I have 2 more minutes. I'm going to close this workspace. Lucky that I prepared a couple other demos. So here's the World Bank sample. Yeah, it doesn't look like we have web. But hopefully I can still run it. So there's a lot of features that are included in this IDE for basically development similar to Visual Studio. So you can use NuGet packages, you can use all kinds of convenient features, but the nice idea here that you can do it online. So here's a World Bank database application. I think it's even less than the other one. It's less than about 100 lines of F# code. And it allows me to actually, on the fly, surf this particular database that I'm going against, and this is called the World Bank database. It has data on everything you can imagine. So I'm picking something, let's say, urban development. Then it goes into the database dynamically. It fetches all these different measures that I can do. Let's say I pick one, population in the largest city, and I say update based on that measure. And I think it will say, yeah, there we go. So here the most dark blue means 36 million something. You can probably imagine that that's a city in either India or Mexico or Brazil. And in fact, and even the US has a relatively large city somewhere in the US. So this is basically a map that shows that distribution. I think I'm out of time, just 2 seconds.
Yeah, really out of time.
Cool. And, so
but you can answer in 1 sentence why
yes.
F# is better than Elm.
I knew that you guys didn't read the first 2 slides, but we didn't have time to actually cover that. So if I wanted to answer that question quickly, I would say that because F# has a huge framework, so it has basically access to all those libraries that other .NET people have ever written. It totally interoperates with everything in C#, in VB, whatever. So I can subsume all that, plus I can contribute to those projects in F#. So I can use functional programming, and with tools like what I was showing, and this is a tool called Web Sharper, which is this framework that translates F# to JavaScript. I can actually write web applications, web-based mobile applications, with very small amount of F# code, and I can plug that into existing legacy .NET applications, etc. But why F#? Another answer is basically F# was the first open-sourced .NET language compiler, and it's available on pretty much any platform. It's available through Mono for Macintosh and Linux, as well as Windows. So it has a wide reach.
Okay, do we accept this answer? Yeah, we do. Thanks a lot. Thank you very much for your presentation.